and welcome back to the second part of our discussion with Kjell Carlsson, who is Head of Data Science Strategy at Domino DataLab. In the part one of this discussion on generative AI and large language models, we were talking about the hype over generative AI and should organization actually look into this if we are going at hype or not. So is it the word for enterprises actually to look into generative AI? In this second episode, we are actually looking a little bit closer in how to make it happen, how to operationalize it in your enterprise. And Kjell, welcome back once again. It's truly an honor to have you here. And thank you for a wonderful conversation we had on the first part. For everybody that didn't listen to the first part, it's super great. I recommend it. Go back. We went through the hype. We went through why people are talking about it. We discussed the difference between applied or traditional AI in generative AI, artificial intelligence, how organizations are approaching it right now. Should they, what kind of a talent they should have for this type of technology? What is the value? Are any case studies out there that are showing clear value at this point of time? Where are we in the maturity when it comes to the generative AI? And we discussed that we are basically right now getting out of the panic mode and moving into the experimentation phase. And then basically we discussed a little bit more about which industries do we see currently mostly investing in this technology. So now what we are discussing a little bit more about how to make it happen. And Kjell is a great person to speak with that. He is basically helping a lot of organizations making that happen right now. So Kjell, let's start with, let's continue where we stopped actually. We talked about that companies should be looking at AI in general. Then if they should deploy generative AI or applied or traditional AI, that is a different thing, and it's a matter of the project or the product or a challenge that you have to solve. But if you're talking about generative AI in general, we were talking about that the maturity right now is moving towards experimentation. And probably in this case, you will either try to operationalize already ready products like maybe OpenAI and Google and etc., or experimenting with small large language model that are open source in order to create some kind of a value in the organization. So in your opinion, so where are we right now when it comes to challenges that needs to be overcome for us to basically generate the value that we want? What do you see as the biggest challenge stopping companies from getting value from generative AI?
Yes, well, as my former colleague over at Forrester used to say, Michael Thierry, it's like there's no joy if you can't deploy, and that applies on AI machine learning generally. It's if we can't at the end of the day go in and get these models into production and for them to work quickly, accurately, and cost-effectively enough, then what on earth are we doing here? Yes, there's certain instances where the process of going through and developing that model can give you enough insight that maybe that business insight's worthwhile. That was the very old applied analytics, applied statistics approach towards AI. But for what we're talking about now, where we're talking about transforming processes, about embedding models and AI-based applications throughout your organization and becoming a core part of your business, again, there's really no point in doing any of these things if we can't actually get them into production. And perhaps unsurprisingly, this feels a little bit like history repeating itself. We're discovering that you cannot outsource your generative AI capabilities because, for a couple of different reasons, but the core one of them is because you can't operationalize it, especially not if you're starting with these ultra large, giant, generic generative AI models. We're thinking there of like Palm 2 or certainly GPT-4, etc. They're just too large and thus too expensive, and too low latency, and they're too difficult to go in and fine tune in order to get the accuracy that you need. So they're wonderful for getting to an MVP, but not for getting to an MVP for taking you down a route that you would then be able to go down for operationalizing this. And So part of this is on that outsourcing part. Previously, a lot of organizations have kind of hoped that, well, maybe I don't need to build my own generative AI capabilities. I'll just be able to rely on these third-party providers for that. Again, history repeating itself. Do you remember the Watson AI APIs, where you could consume various different models as a service, whether that be personality insights based off of, you feed it tweets of an influencer and you'll find out interesting things about their behavior, or image and video recognition use cases, Amazon AWS recognition, or Google's Vision AI. Folks invested a lot of time and energy in creating these, in those cases, deep learning models available as a service. And it turned out, well, your data is too different. Your use cases are too different. If you were a large social media platform looking for a content moderation model that would be able to detect guns and gore and nudity in user uploaded photos, that's fine. Well, we can create a standard model that can sort of do a decent job working against that for most organizations. You then start moving beyond that to anything else, and all of a sudden, there are few commonalities between the data and the use case in order for the models as a service approach to work. And that's what we're discovering on the generative AI side of things. It turned out that there's both physics and organizations conspire to make it no more feasible to create some sort of giant, super intelligent model in a vat that you can then go in and leverage on without doing any of the work yourself. Unfortunately, it turns out no, we can't escape the usual process of going in and refining our use case, refining our domain, fine-tuning on a specific set of data that you need to use, and going through the really painful process of going in and operationalizing that complex pipeline that forms the basis of a generative AI model or a generative application.
Would you say that it's harder to build a real-world generative AI model than a normal applied traditional machine learning, deep learning AI model?
Yes, I would, for two reasons. One of them is that with these generative AI models, they're a little bit like a regular deep learning model on steroids. The data volumes are much larger. The infrastructure needed to train them is much larger. Even the infrastructure needed to inference them is much larger, and the challenges around evaluating them and monitoring them are an order of magnitude harder than they were with traditional deep learning models like convolutional neural networks, let alone traditional machine learning models like random forest models, etc. So part one is just the challenge of these models are giant and everything that results from them. But part two is there is an element in the complexity of the application, the complexity of that pipeline. We were talking about a simple generative AI application previously, and how it's not consuming one model, right? It's consuming a whole bunch of different embedding models. It's then going in, which are then, stored in a vector, passed to a vector database, retrieved from a vector database. Then it's going and creating a whole set of different prompts that it's feeding not just to a model once, it's feeding to model multiple times, sometimes multiple different types of models, ideally multiple different types of models, and then feeding the results of that into additional models for additional processing in order to generate something at the very end. And the more different types of functionality you have, the broader, the more that pipeline, that workflow explodes. So it was already hard enough to go in and operationalize one of those models in that pipeline. All of a sudden, I'm now needing to operationalize a whole host of different models, really a whole host of different technologies, technological components in this, and a lot of them, very few of them that are integrated. And do this at an infrastructure scale that is very expensive and slow. So yes, part of this is just, a regular challenge is just harder. And part of this is, no, there is an additional layer of challenges that we sort of had before, but nowhere we could get around it with chewing gum and sticky tape. And right now we need to have more scalable processes for dealing with it. And that's a new challenge for folks. So I guess this gets into the question of, is LLM ops or ML ops really the same thing? And, or is it different? And the answer is yes to both questions.
Right. I got triggered a little bit by something that you said earlier. Is like, so if it's more difficult to build than a traditional data science machine learning model, and you were talking about outsourcing before, why don't you outsource the creation of a generative AI models or the generative AI strategy? Or the strategy should be internally, but the creation of it to a third party company.
Well, I think right now, one of the issues is that they don't exist. I mean, this is a little bit in the build, buy, or hire, where I guess the build would be to do everything yourself. The buy would be leveraging third-party generative AI models as a service. And the hire would be going in and hiring a consulting company to go in and take your data and maybe find those open source foundation model to basis off us, do the fine tuning of it, and then build that application with all of the prompt engineering, RAG, fine tuning, etc. And do the validation for it. Right now, I think the issue is that we don't have enough folks who are in that gap. The market for data science consulting firms was pretty thin. I mean, there are a lot of them out there. There are not that many which have been able to get a whole lot of scale and traction. And certainly when I was an industry analyst at Forrester, it was really very depressing to be in touch with the very, very large management consulting firms just to see how little that they were doing on the cutting edge and putting in production on the cutting edge. Most of it tended to be more well-defined projects like intelligent document processing and those ones, no problem. You move beyond that, and then they hadn't invested in it for the same reason that but not. It's not their fault. The customer demand there was also challenging.
Yeah, but it's also about talent, right? And if you don't have the right talent in your organization, then, and if you're selling talent, then it is what it is, right? So
there's the talent, and there is the component of the talent which is really, really understanding your data and really understanding your systems and your use cases. And for a management consulting firm, the moment it starts looking like something which is more specific to you and not a broader problem that everybody faces, the less appealing it is. And that's the problem with data. It almost always looks very specific to you. And so in the build, buy, and hire, to the extent that you can, obviously, this is never an either or. You should probably be doing all of those. The problem right now is that folks are hoping that you can go and just do the buy route, that we can just go in and buy these models of service, and I won't have to do a whole lot else around it. And that seems to, unfortunately, that's the wall that folks are running into and discovering, oh, I created this wonderful MVP and now I don't know where to go next. So the complementary side of the build side right now is the only real place that I'm seeing folks get meaningful traction creating an application that isn't just serving like very, very ad hoc needs. So again, if all you really wanted to do and what folks need to do is just get a very generic first draft of a sales email that I'm sending to folks, I can probably buy that. But the moment that I try and go beyond that, I start running into massive problems, both getting the accuracy that I need, but also getting this into production.
Right. So we understood that developing these generative AI models is a little bit more harder, one would say, than traditional ML AI type of products. But you cannot outsource it yet because there is not a lot of companies actually that are working with this out there. So which means that we are left with the talent that we need to have inside the house. So
yes, although I would say there are limits to how much we will be able to outsource it even in the future.
Yeah, exactly. Because, and now regulation is coming in, etc. Especially when the AI Act is going to boom next year. Outsourcing is almost. I mean, many of the organizations. If I'm an enterprise owner at that point of time, I would like to outsource the deployment of AI model, because if something happens, you blame them instead of yourself. But depending on how the AI Act is done, but there is going to be quite a lot of. I truly believe that outsourcing will become a very big part, especially of the maintenance of AI models in future. And maybe even
there's certainly certain use cases that should be easy to peel off.
Right.
Like, again, a core use case that I'm seeing organizations go after right now is, as we mentioned on the previous one, creating some sort of virtual assistant on top of a corpus of textual documents.
Right, exactly.
And that's one where it is similar enough. It's almost a guarantee that at the very least you should be able to have third parties be able to build one of those for you. But we're likely going to be seeing some pretty decent solutions off the shelf that you'd be able to consume. Much in the same way that, you know, how many people are really building their cognitive search capabilities from scratch right now? Why would you? But you're either building one that either exists off the shelf, or you're hiring in one of those myriad different organizations that are taking some open source technology or a proprietary one and building you something off of it. Right. And so we should see that with some of these use cases. But the closer it gets to what's core to your business, the more and more you're going to be building it yourself.
Right. And then with the prompt engineers and what you have in-house, is that enough to build?
It would certainly be lovely if it was enough, right? If prompt engineering and retrieval augmented generation were enough, and we could just use a model that was off the shelf, things would be wonderful, right? Because it's when you get to the fine tuning is very computationally intensive, but also then the evaluation off of that is very messy and difficult. So a lot of folks would like to be able to stop there and not have to do the fine tuning. The reasons why you want to do the fine-tuning is because obviously no matter what you do on the prompt engineering and RAG side of things, you are always able to get higher accuracy from your model with fine-tuning. Now, okay, but what about if it's good enough? Well, then you run into the next issue is that, well, sure, you were able to get that accuracy that you needed on a giant model that you couldn't operationalize. So the key reason why you need fine-tuning is because you're not doing fine-tuning on a giant model. You want to swap out that giant model for a much, much smaller model. So think 2 billion parameters, 7 billion parameters, 40 billion if you absolutely have to. But ideally smaller than that, significantly smaller than that, as small as you can get. And then you're doing fine-tuning on that. So it's really more of an optimization challenge, which is driving the need for fine-tuning more than in most cases, the accuracy. Sure, if you're doing something crazy like the pharma folks are doing, where they're taking a language model and fine-tuning with molecular data, you're never going to be able to escape that. They're not doing that because they need efficiency. But for everybody else, it's I can't go in and put 100 billion plus parameter model into production, and certainly not in the way that that would make for a good application where I need to go and hit that model over and over again. I need something tiny in comparison. And to get a good enough accuracy for that, now I need to do fine-tuning.
Right. Well, this is a good segue actually to the next topic, which would be a little bit more LLM ops versus ML ops, right? So what would you say are the capabilities needed for operationalizing generative AI? And how do this differ with the traditional ML?
Yes. I mean, there's certainly the ones which are just the same as MLOps on steroids. Right? So it's okay, I was able to deploy a model, but a very small model. And now I need the ability to go in and deploy a much, much larger model on it. So some of them is just, okay, I need more infrastructure. I need a framework which can go in and distribute. I need just the same capability that I needed always before, of being able to not just provision the infrastructure on the development side, but also provision the infrastructure environments on the deployment side of things. So needing now GPUs and Selden or something like that in order to be able to go in and deploy those models. Well, we were doing that before in standard MLOps. So this is just making sure that we're getting those capabilities up to good enough, up to modernizing those more state of the art, and being able to do this faster than we did before. We all know the horror stories of it taking months to get your models into production, because not just the technology side of it, but just the people and process side of it was so difficult and broken. So both on the technology side as well as the process side of things, there is an upgrading that needs to happen with the same MLOps capabilities that you were going after before. The thing that is different on the generative AI side of things is, one, it increases the need for sort of openness and extensibility, because the model that you're going to be using right now, there's so much innovation going on in so many different locations. There are no winners in terms of a model that is best size fits all for all of your different applications. Right now, it's it might be Falcon 7 billion parameter over here. For this one, it might be Finbird. Over here, it might be Mosaic ML or something else, or Llama 2 or one of those other ones for yet another. But right now, there's no way to, there are no clear winners, or certainly the who's winning varies from week to week. And certainly as you start going and looking at your individual tasks, those models start performing very differently from each other. So there's this need to go in and be able to consume models from different sources, sometimes that are either open source or licensable that you can consume on-prem, some of those that are going to be in one or different clouds. There's the need to go in and be able to then integrate your vector databases with these so that you can leverage RAG, for example. There is a need to be able to have a lot more complex verification. There's also a need for a lot more complex experiment tracking, because you end up having a proliferation of different variants of these models that you need to test. So there are the openness, the ability to go in and leverage a model irrespective of where it's coming from and where it's living, and an environment that can support it. That is a new capability. There's obviously a new capability of being able to support more complex data ops as part of the pipeline, specifically when it comes to vector databases, in part because a lot of those vector databases won't operationalize your embedding models. So sure, they're happy to take the output once it's already gone through an embedding model and serve that up, but they're not running that. So now you run into a front end and back end problem of, okay, I need to take this incoming data, I need to go and put it through one set of models, feed into the vector database, and then get it on an as needed basis for these other models that I want to process this through. So the data ops part of this is more challenging. Obviously, infrastructure, very different level of scale, very challenges there. But then there is that challenge of, well, but now how do I orchestrate those complex pipelines that we were talking about? Right now, especially when there are complex pipelines that are working across various different technology components. So you have this need to orchestrate this ecosystem of different technology components with very high performance requirements in a way that, yes, sure, we had traditional AI pipelines that would consume multiple models. They did exist, right? Well, for sure. I mean, every time you went through an NLP use case, you were using one of those. But it's not at this level of complexity. Now, this is something we haven't seen really before. And now you're more orchestrating the entire AI application versus then you're orchestrating individual models.
Right. And but then it must have some pros and cons, right, in dividing the strategies. So what will be the pros and cons? And, thinking about LLM ops and ML ops as two separate things.
The benefit of thinking about it as separate things is that if we just call this traditional ML ops, we're going to be stuck with the capabilities that we have. A lot of organizations think that MLOps, we have an MLOps platform. We solved MLOps. So therefore you can go and use that when you need to go and deploy your LLM. And it's like, not really. No, it's not meeting those needs either in terms of the scalability of the infrastructure or the kinds of models that we need supported or those other components of this that we need to integrate in this. So that's the downside of just saying, LLM ops is really just ML ops. Is that we're not going to get the investment that we need in order to beef these up to be able to support those new generative AI use cases. Now, the other problem is, okay, if I'm just thinking, oh well, so now what I need is an LLM ops platform, and there one is very little consensus around that, what that is, and it's very likely that they're going to be narrowly focused on one model architecture for one set of use cases, versus be able to provide you any of the flexibility to both integrate with your traditional ML ops platform. You're not going to get the benefit that that kind of platform would have for all of your other traditional ML use cases, and likely it's so early that's probably not going to really be terribly future proof. It's probably going to not even support your full range of generative AI use cases, let alone the future generative AI use cases that you're going after. Because right now it's too new, and anything which is new that is offering you an LLM ops platform is probably not mature enough to really be able to grow and scale. But as a capability, it's helpful to think about them separately and think about a unified strategy for growing your combined ML ops and LLM ops capabilities.
All right. Let's take this angle because I think it's a very important angle to take. Most of the companies are right now a little bit reluctant to even consider utilizing general AI, partially because of their data literacy and AI literacy and etc., and understanding for which cases they should use it. But that doesn't take the second one, which is actually more important. Can we trust generative AI? Can we deploy such technology in our organization? So my question to you would be more about governance, actually. So how to implement security measures or some kind of guardrails, let's say, to ensure that these generative AI can be trusted and they're secure for the enterprise itself and for all the people to use it, right? Because there were some cases, if you remember, companies like dropping their personal identifiable data inside and etc., and then it was a big scandal. So can we trust them, and how do we make sure that they can be trusted?
Yes, I mean, that is one of the reasons why one of the things that is driving folks to go in and deploy open source LLMs on premise is part because of there are plenty of organizations out there that are hesitant to put their data in the cloud, and even the ones that are willing to put the data into the cloud, there is this desire for controlling the model in a way that a lot of even OpenAI is really a startup and functions a lot like a startup. How even if they are guaranteeing the safety and security of your data that's being submitted there, are you willing to take that risk? Maybe for them, maybe Microsoft has worked with them enough in order to harden a lot of those things. But what about that broader ecosystem of folks who have that specialized tailored model that gives you the performance that you want and that you're more likely to be able to operationalize? What about them? Hence the desire to go in and have a whole lot more control over the operationalization of those. So that element of it is there, but I feel like I'm jumping the gun. There is an element here about, well, how do you develop trust in any AI or machine learning model? And I had the benefit of interviewing Gregory Zuckerman, who wrote this, who's at the Wall Street Journal, who wrote the book, The Man Who Sold the Market, about algorithmic traders leveraging artificial intelligence. And it's like, well, how did they solve the trust problem when, what they're doing was very opaque, and you were very literally handing over those decisions to the model. The model had to make those because they were not ones that you could have human in the loop for, because you couldn't afford that kind of delay. And the more that they see the model going in and doing order behavior, the scarier and scarier that is. And so how in those situations do you provide trust when there's a limit to how much how much transparency, explainability that you can provide to these, and certainly in a way that any customer would understand. And there's abnormal behavior. There are things that happen that you haven't seen before, that you haven't been able to test your model against. And what was key there, I think, is key for all of us in anything that we're doing on the AI side of things, which is trusting the model really is about trusting your people and your processes. And so if you don't have your processes in place in order to provide foundational governance, and you don't have people in place who think that it's important and know how they can go in and test and evaluate these models beforehand and ensure that those processes are working, really everything else that we're doing is just castles on sand. And that's unfortunately what happens a lot when it comes to trust in AI. Folks are thinking, well, we can go in and put in an AI ethics council, and that's going to be able to do it. Or we're going to espouse these ethical AI principles, responsible AI principles. And as long as we hold to these principles, then that's going to ensure that we are trustworthy. Mm-hmm. Well, no, it won't. I mean, there's value in having those ones and making sure we don't go after unethical use cases and so on and so forth. So I'm not completely discounting them. But if you don't have your processes in place for ensuring that models are rigorously evaluated, that you have independent validators for them, that you do have testing processes, in across the different stages, if you don't have documentation, if you don't have an ability to reproduce your results, if you don't have that constant tracking of what data was used, what model was used, what prediction was given, and so on and so forth, well, then all the other stuff it doesn't matter. And so I think there's just so much basic housekeeping that we can do at that level of ensuring that we do best practice governance for machine learning model development and AI model development, that if we just go after that, we will automatically put ourselves in a much better position, irrespective of the new use cases that we want to go after or what regulation that comes at us.
Right. I agree with you. So we started with data governance some time ago. Many companies are becoming quite mature when it comes to data governance. Now AI governance came as something new. And if you look at the world where we are in 2020, 30, where every single organization will have hundreds, if not thousands, of machine learning models in production, probably right now is the right time to think like, okay, how this will look like. And it doesn't matter if it's applied or generative AI, you need to have governance in place, which will help you want to secure and to make sure that you have a good output of value, but in the same time to manage risk, because with the regulation, that is, it's something to attend to, right?
I think folks are often scared by the magnitude of the problem. So right. Especially when you take it on the generative AI side of things, this is oh my God, how am I going to go in and control this model when people could feed it any prompt, right? I mean, how do I ensure that there's always going to be something that I didn't think of that somebody is going to ask to this model, and that they're going to be able to get some sort of unexpected output, and they're going to go and post on social media. And yes, right. That is a really difficult problem to solve. But what about the baby steps? What about just knowing what models were trained? What were they trained on? What outputs were there from those? What were the test results from these? And just being able to go in and diagnose those problems would be a good first step. Or have sort of bare minimum testing across all of these. And so yes, I fully understand that there are certain use cases with generative AI. They're external facing. Your customers are going to see them, where you're trying to mimic a fully human-like interaction. Those are the hardest to go after, right? Maybe we don't go after those ones. There are plenty of much lower hanging fruit when it comes to generative AI. There are all of these augmentation use cases where it's human plus machine. There are plenty of these internal use cases where it's providing its results to one of your employees, and not to an end customer. There are all of these things that we can do that don't force us to confront the absolute hardest governance challenges.
Yes.
And at the same time, that will get us on the path to get there. And I think a very helpful example here is really start looking at regulated industries today. Look at financial services, insurance, the healthcare space, and look at the processes that data scientists do there, right? Because they've had the incentive. The main reason why we've underinvested in these capabilities is because often the financial incentive to shirk is there, right? It's like, well, if I don't have to, why am I going to go in and hire folks and dedicate time and implement technology that will go in and do this for us? The regulated industries have had that incentive for a long time. Let's learn from them and what they've built in terms of guiding us on what we need elsewhere.
Yeah, and that is a good industry example, because when I'm speaking with the community in the financial institutions, it seems like they are on the forefront. They are not basically lagging behind, although they are much more regulated than any of the other companies. And they are also restricted to work in a hybrid type of environment, not only cloud and etc. So yeah, I think that is a good actually way to put it. Let's conclude a little bit with your outlook or your view on the outlook of how this is going to go in the future. How do we go ahead of this rapid innovation and potentially dramatic increase of demand for generative AI projects and products?
Well, I mean, the benefit of having to look ahead in the generative AI space is that, well, looking ahead is like looking ahead like 2 to 3 weeks, in the sense of the innovations are flying so quickly that that predicting the future, actually don't have to predict very far in advance in order to be predicting the future. There always seems to be some unovercomable problem that, well, somebody mysteriously seems to have been able to solve some component of it. So thankfully, I don't think we've had many AI winters. I don't think we're going to hit an AI winter of that kind. We seem to have stumbled upon something which is very core, something which our brains do. And by having stumbled upon that one innovation, that attention mechanism, that ability to create that next best predictor model for language use cases and the next pixel to create and things like that, actually is so much how our own brains work, that having unlocked that, we unlock all this incredible number of use cases. So I don't think this is going to be like even like 2012, 2013, where it's like, it's amazing. Now we have to wait 5 years to see much of a result from this, or heaven forbid, those earlier generations. Now the cat's out of the bag. What's instead we have to worry about is just that the executive appetite for this, the belief that we can drive business impact off of this quickly. That, I think, is where we are guaranteed to hit some sort of trough of disillusionment at some point. But unlike in past eras, whereby this really set back all of the use cases we want to go after, there's just too much low-hanging fruit. It's too easy to go and create applications that provide value, because the bar of improving human activities for so many of these things that we're doing is just so low that, if we just give somebody that slightly better draft that they can work off of, you've already saved so much value for the organization. If we make it slightly faster for them to comb through all of the data that they need, you've already provided that value. So there are certain use cases, I think, that they're going to take off, but that willingness to experiment for the moonshots, for the crazy ideas, that window of opportunity isn't very long. And I think the willingness to go in and do those is, and for us even to be able to actually hit a lot of those, I think is it's questionable whether we're going to get to those soon.
Right. Good. I think that we covered quite a lot of ground in this 2 episodes of almost 1 hour of content. Kjell, it was a great pleasure to have you here. But before we conclude, tell us a little bit about how Domino DataLab is looking at this, and how are you addressing this current shift to generative AI?
Well, so for us, it's always been about supporting usually the most difficult tasks that data scientists have to work with, either on the technology side of things or in terms of just the people and process side of things. And so we try and help data scientists with everything that's miserable about being a data scientist. So all of those ability to integrate those different infrastructure components, those being able to leverage the technologies from different sources, be able to access data and infrastructure in different places. We try and help folks with that by creating all of the connective tissue around that. So for us, generative AI is absolutely wonderful because so many of the challenges of generative AI are the challenges that we've been looking to solve for a really long time, that we've been helping folks with. Does that mean that we have answers to all of the problems? Absolutely not. I wish anybody could. I wish there was an easy button that we have for this. Yeah. But for us, the route that we're taking is this one of integration, being able to enabling folks to leverage the infrastructure they need, the technology packages they need, and do that in a governed setting where everything is tracked, and help make their lives a little bit better and certainly a lot more productive along the way.
Perfect. So that is a great closure for this Hyper Data Talk. So thank you very much for joining us. It was a true pleasure.
Likewise. Thank you very much for having me.
Yes, we will continue our discussion in a couple of weeks on the upcoming event. So it will be nice to see you as well. For all of you listening, thank you very much. Make sure that you view the part 1 of this interview with Kjell Carlsson, head of data science strategy at Domino DataLab, and follow us for more interesting and exciting interviews on our channel, Hyperight Data Talks on YouTube or here on LinkedIn. Thank you, and until the next time.